Hello class. Today we are going to be working on the L2A notes, which is going over systems of equations. Systems of equations are going to be a set of two or more graphs. Now these graphs can be any type of graphs, but specifically in this unit we will be focusing on solving systems of linear equations. When solving a system, the solution is going to be the point that makes both equations true. So let's go ahead and take a look at what that means for our graphs. So for question number 1, we are asked, is 2, negative 1 a solution to this set of or system of linear equations? All I've done so far is just copy down each one of these equations below so that I can do my substitution without having anything underneath of each one of the equations. So in order to determine whether or not 2, negative 1 is a solution, I need to substitute in, and then I'm going to see if I get a true statement, then I'm going to say I have a solution. So I want to see if I get a true statement. If not, if I get a false statement, then I will be able to tell that I do not have a solution. So let's go ahead and see what I get, whether I get a true or false statement once I substitute in my x and my y. So where I see an x here in my equation, I want to replace that x with the 2. And where I see a y value, I want to replace that with a negative 1. So 3 times 2 is 6. And then a positive 2 and a negative 1 give me a negative 2. So I get 6 minus 2 equals 4. And then 6 minus 2 is 4. And I am setting that equal to 4. 4 equals 4 is a true statement. So far I am good, but with a solution for a system of equations, I need to make sure that that is going to be a solution for both equations. One of them is not good enough. So I need to go ahead and substitute in my 2, where I see an x. And for my y, I'm going to substitute in a negative 1 again. So I get a negative 2. A positive 3 times a negative 1 is a negative 3. And setting that equal to negative 5. Negative 2 minus 3 is a negative 5. So again, negative 5 is equal to negative 5, and that is a true statement as well. Now that I can see that 4 equals 4 and negative 5 equals negative 5 both give me true statements, then I can say that 2, negative 1 is a solution. Okay. Now I want to see if number 2 is 3, negative 6 a solution. So again, I'm going to go ahead and plug in my x value and my y value. So my x is a 3 plus 3 times y is my negative 6. And I want to see, is that equal to 15? Here I get 3 minus 18, and that is going to give me a negative 15 because the 18 is bigger. Its sign wins. A negative 15 is not the same as a positive 15. That is incorrect or false, so I can already say that 3, negative 6 is not a solution. I would have had to have had both of them be true in order for it to be a solution. So as soon as I get one of them that's false, I don't even need to check the other one, because as soon as one of them returns false, then I cannot have a solution here. All right, let's go ahead and take a look at our next portion of our notes. So a little heads up of where we are headed in our notes. We are going to be looking at 3 ways of solving systems of linear equations. The first way that we're going to be looking at in this video is solving by graphing. Then we are going to look at solutions using elimination and substitution. With any of those 3 methods, I would get the same answer given the same set of equations. So I can solve this set of equations here in question number 3. I can solve this set using either graphing, substitution, or elimination, and it does not matter. I would get the same answer no matter what. So let's go ahead and see how we would solve this using graphing. So for part A, or the first step in graphing, I want to make sure that the equations are in slope-intercept form. That's your y equals mx plus b form. Basically, I need my y by itself. Part B, or step 2, I'm going to graph both of the equations and find the intersection of those 2 lines. And then I can check my answer by substituting the solution back into the original equations. Since I already showed part C in questions number 1 and 2, I won't be doing that again in question number 3 and 4. So question number 3, I am going to double check, are both of my equations y equals? I would say yes. Both of these have the y's by themselves. So I can go ahead and say step A is done. Now I want to double check, now I want to go ahead and graph these and find their intersection. So they gave me a y-intercept here of -12 for my first equation. Let me actually grab a different color here. I'm going to go ahead and graph this first line in purple, and then when I get there, I'm going to graph the second equation. Let's do orange, purple and orange. Okay. So the first equation gave me a y-intercept of -12, so I gave myself a couple of extra lines down here so that I could graph the -12. That's my y-intercept, and from there I'm going to go ahead and graph the up 3 over 1. So 1, 2, 3, right 1, up 1, 2, 3, right 1, and just going to continue that pattern using the slope to work my way up through the entire sheet of graph paper. And then looking at the orange graph, I want to this time start with a y-intercept of 3. And because I have a -2 over +1, I'm going to go ahead and drop down to right 1. I only want one of those to be in the negative direction. So since I'm already going down 2, I will go right 1. And then in the opposite direction, if I'm going up 2, I'm going to go left 1. And here, my intersection point, grab this in blue. My intersection here will be at a positive 3, negative 3. So my x value is positive 3 and my y value is negative 3. Your answer for a solution to a system of linear equations is always going to be a point. So you should have both an x and a y value for that solution. In our next equation, we are given two equations that are our special equations. If I have a x equals some number, that is going to be a vertical line, and y equals some number is going to be a horizontal line. We learned this in the last section. So x equals some number. These two equations don't follow that y equals mx plus b format that we're seeing in the other equations. So we just need to remember that we have to have this memorized. X equals some number is going to be vertical, and a y equals some number is horizontal. So I'm going to go ahead and graph again. The top equation we'll do orange, and the bottom equation we'll do in purple. So my top equation, x equals 4, is going to be a vertical line at my x value of positive 4. And my purple line is going to be a horizontal line at where my y value is equal to negative 2. My intersection for those two then will be a x value of 4 and a y value of negative 2. So 4, negative 2 is the solution for question number 4. Let's go ahead and do one more before I let you practice on your own. We'll do this line as purple and the top as orange. I want to make sure that I have y equals. I do for my orange, so I'm just going to go ahead and graph that backwards. I'm going to start with the 2 and then use my 1/1 slope as my pattern from there. And I do want to just go ahead and take a second to draw that all the way across my graph. All right, now that that equation is completely graphed, I can go ahead and focus on my purple equation. Now, before I can graph this, I have to recognize that my y is not by itself. So let me go ahead and rewrite this off to the side so that I can get my y by itself. I'm going to go ahead and cancel out my x's. A positive x and a negative x will cancel. And I'm going to drop down my y. My x value is negative, and my 4 is also negative. I want to make sure that I bring those signs with, treating them, the sign is the property of the thing that follows. So the sign of x, the property of x is that negative sign. So I want to go ahead and again graph this backwards, starting at the negative 4 along the y-axis. And then I'm going to go up 1, left 1. And keeping in mind that this does need to be a negative slope, so I need to make sure that I head off in that negative slope direction, which is this way. And using my pattern, I have come up with the equation, the graph of the equation for question number 5. Now I can find my intersection for those 2 points, and I get a intersection of -3, -1, and that is my final answer for question number 5 is the intersection there. I want you guys to go ahead and try questions number 6 and 7 on your own. I would like for you to go ahead and pause the video here, and then once you unpause this, I will have the answers displayed. Hopefully you've had a chance to try these on your own. For question number 6, I ended up getting -3, +1 as my answer for the intersection there. And question number 7, I got 3, -2 as my answer for the where those two lines intersect.